so in this video, we're going to start looking at using outside features customly built for Python. So kind of going beyond the scope of everything that's built into Python directly, and using custom-made features for it, or libraries. And so what these are packages that you can import that already have a bunch of functions defined, that already maybe have classes and other types of features that are ready for you to use, so that you don't have to create everything yourself. And so this is one of the really great things about Python, is that there's a really big community, and there are a lot of packages designed already so that you don't have to build everything from scratch. You can use everything that's out there, and you can use all the important things to just kind of join it all together, to write your program as effectively as possible, and to never have to, or maybe never, but not often have to reinvent stuff that's already out there. Yeah, so that's kind of the idea of packages or libraries. So we'll just look at a couple of those right now just to see kind of some examples. And I'll also show you the general syntax for importing them. So let's just start off. And the first kind of library that we want to deal with is the random library. And so what the name already suggests, what the random library brings with it, is a lot of features surrounding randomness, especially random number generation and all that stuff. So yeah, let's just take a look at that and see what we can get from there. Okay, so how would we go about getting this? Well, we have to import it somehow. So how are we going to do that? Well, let's start off. The way we do this is that we type in the keyword import. And so the import keyword allows us to import these libraries, and we have to have them downloaded before. But when we do, then we can import them. And Python has a working directory, or a certain directory that it has all its libraries in. So if you for some reason are getting an error, it will probably be because the library that you're trying to import isn't in this directory. And there are ways to get around that, but we'll look at that later. So let's just kind of stick with the basics. The random library is one of the basic ones that is generally included. So yeah, let's take a look at that, and let's see how to import that. So to start off, we type in the keyword import. And so the next thing that we have to put in is what we want to import. So we want to import the random library. And so this is just the name of the library that we want to import. And so this allows us to get all the features that are contained inside this random library. So the name of the library literally is random, and it brings with it a bunch of functions that we can use inside. So we can just import this, and now we can access everything that's inside this random library. So random, yeah, okay, good. So let's see some examples of what we can do. So let's just start off with the basics. Let's create a random integer. So we're going to save this in a variable called rand_int, just because this nicely describes that we're going to save a random integer in here. And so we're going to make this variable equal to, and what we're going to make it equal to is a random integer that we're going to create using this random library that we have imported. So how are we going to do that? Well, we're going to go inside of the random library by typing in random, and then when we put dot, very, very similar to classes, when we use the dot, we can access the features contained inside. So one of the names of the functions that we are going to want to use is the rand_int function. So we type in rand_int, and we open and close parentheses. And now what we can put in here is we can put in two integers. So one of them is a starting integer, and the other one is the ending integer. So if we, for example, want a random integer between 0 and 10, we would put it in like this. So let's just put in the comments behind. We put in start, and then we put in end, like this. And so our numbers are actually less than equal. So we got less than equal to the start. That's our random number. And the random number is also less than equal to the ending number. So it's not like the range kind of function where we end at 10 and we go up to but not including. In this case, we go up to and including this final number here. So what we're doing is we're going inside of this random library. We're going to access the rand in function contained inside. So we use the dot to say that we want to access something inside of this library. Very similar to how in classes we use the dot to access a method inside of a class. Here we use the dot to access a function inside of a library, and we just put in our parameters. In this case, the rand in function takes two integers, a starting and an ending value, and this gives us the range or the scope of the random number that we're going to generate. So it's going to be between 0 and 10. So let's just print out this rand in this random integer that we've created, and let's run our code. So in this case, we get 1, for example, and now we can run our code again, and in this case we get 9. So yeah, it creates a random integer every time. And so how does this work? Well, there's a special kind of function inside of random that generates the random integers. So this isn't completely random. This is kind of pseudo-random, so it's a perceived kind of randomness, but it's faked. It's based on an algorithm. And we can actually set the starting value of this algorithm. So usually the starting value of this algorithm is just set as the local time, or as not as the local time, but as the current computer time if you don't give it an argument. But if we want to set it as a certain value, we can always set the seed. So that's what it's called. The starting value is called the seed. So for example, we can go into random and we can set the seed, and then inside here we can put in an integer, for example, and so this is gonna set the starting value. So this may be if you want to start creating random numbers but you want to create a certain seed. And so the reason I'm showing you this is just to kind of give you an idea of what's actually going on behind the scenes, in case you're interested. So generally we can kind of just use this for all purposes. You may not want to use it directly for security because it's only pseudo-random, so it may not be that secure for generating random numbers. And that's because it's based on an algorithm based on a starting value, and that gives you a random output number. So yeah, but let's see. If we run this, we get 2. If we run it again, well, we get 2 again. If we run it again, well, we get 2 again. And well, if we run it one more time, we get 2, and you can probably guess what happens if we run it one more time. So yeah, you kind of see the idea of what happens when you set a seed, for example. So the seed gives you your starting value, and if your starting value is always constant, you'll always get the same constant output that we see here. So you can use this to your advantage. You can also use this to your disadvantage. You also don't have to implement it at all because it's taken from your computer time and date and everything. So you'll definitely be assured a certain amount of randomness from that. So you really don't have to set this. This is just one of those extra features that you can put in if you like, but it's not necessary, and it's mostly there just to show you what's going on behind the scenes so that you can kind of understand this isn't completely random. This is just random looking based on an algorithm that takes in a certain starting value. But yeah, anyway, I mean, it still works great, and we can still use it for a lot of stuff. So what are some other things that we can do with it? Well, we can also create a random floating point number, so a random decimal number, rather than just creating random integers. So maybe we want a random floating point number. So floating point is just the decimal number. So we can call this one rand float. And so there is a function for this inside of random. So if we go inside random, and here we access the function called random. So inside random, we access random, and now we just have to open and close parentheses like this. And what this does is it creates a decimal number, so a floating point number, between 0.0, less than or equal to the number that we're going to create, less than 1.0. So what we're doing is we're creating a random number with lower bounds of 0, so including 0, and upper bound, but not including, so kind of asymptotic, is 1. So you're creating a random floating number between 0 up to, but not including 1. So let's print out this rand float, and let's see what we get. So here we get our random integer, and now we see it's different from 2 because we set the seed, or we didn't set a seed, and so it's taken as our computer time. And here we see the random float that's been generated for us. If we run it again, we'll see different values, and if we run it one more time, here we go again. So yeah, cool. These are both really, really cool functions. But there are more. So there are actually many more. We can take a look at a couple more. So let's look at another one called uniform. And so what that does is our random float here actually only creates random floats between 0 and 1. But what if we want a bigger range than that? 0 and 1 doesn't really cover everything that we may want. What if we want to cover a bigger range than that? And so we can do that using the uniform function. So rand uniform is just gonna represent our random uniform. And so let's just write this out and then let's explain it one more time. So inside of random, we want to access the function called uniform, and then we open and close parentheses, and inside here we put a starting and an ending value. So let's say we want to start at 1 and we want to go up to 11. So how does this look like in terms of exclusion and inclusion? So we have our starting value, and then we have our number is going to be less than or greater than or equal to our starting value, and it's going to be less than or equal to our ending value. So whereas for the random we have in between like this, so asymptotic is the ending value, so not including. For our uniform we actually have an inclusion of the ending value. So yeah, let's print out the rand uniform. And so all we're doing is we're creating a floating point number now, so a decimal number like we've done up here, but in between this range here. So yeah, let's see that in action. So we see here, this is our random integer created, this is our random float, and this here is our random float in a kind of uniform range, so in the range that we specified. We can run it again, and we see we get a different float here. We can increase this up to, let's say, 1,100 rather than just 11 to get a bigger choice. And so this is what we get, 838 point whatever. We can run it again. Yeah, so we get the idea. So this is also really cool functionality. Let's just create random numbers in whatever kind of sequence or whatever kind of range we would require. We can create these random integers, we can create these random floats, these random uniform numbers, and these are all going to be really useful, especially when you need random numbers quickly. So the random library is extremely great for that. But we can also see how nice it is to just have this feature of being able to import other libraries so that we don't have to create this random number generator ourselves and write this algorithm and define all these functions. We can just import this package or this library and just use everything contained inside. So that's really cool. Now there are different ways that you can import. So in this case, we just imported the library. What we can also do is we can import the library and give it a nickname. So what we can do is we can import random as R, for example. And so instead of having to type random every time, we can just replace random by R, or we're going to have to replace random by R. And so what this does is it imports random, but it gives it the nickname R. And so this is useful if your libraries, for example, are extremely long, or you just want to give it a shorter name because it's more convenient. Then you can import it as a nickname. And this nickname is what you're going to be using then to access the library. So instead of going into random, we just go into R. And since we imported random as R, if we're going into R, we're actually going into random. But it makes it a little bit shorter and easier for us.